Good morning and welcome to my explanation on how to graph functions in the family of the parent function y equals b to the x. So similar to the other function families we covered, we're going to talk about the translations, the shifts up and down, right and left, stretches and compressions, as well as a reflection over the x-axis. So first of all, what I want you to see is that this is the parent function, y equals b to the x. The first thing we're going to talk about is actually stretch and compressions, and that is y equals a times b to the x. So we're going to talk about compressing and stretching these functions. And a stretch, similar to before, is where that a factor is going to be greater than 1. And a compression factor is going to be when it is between 0 and 1. So what you can see right here, this red graph is the graph of y equals 2 to the x. And if we give it a stretch factor of 3 and make it y equals 3 times 2 to the x, and we do a table of values, which we're going to be doing to do this, notice how this is stretched vertically in the blue graph. On this slide, we're going to graph the function y equals negative 1/3 times 3 to the x power. And what this is going to be a vertical compression because the a value is 1/3, which is between 0 and 1. And we also have a negative in front of this, which is a reflection on the on the x-axis. So in order to go ahead and graph this, I've written my translations down here in pink. We need a table of values, and as long as we don't have any horizontal shifts, the values that we can choose in our table of values can easily be -2, -1, 0, 1, and 2. And you'll notice I worked these all out for you. If you need to think about how these got calculated, pause the video, take a look at it, and let me know if you have any questions. So when x is -2, y is -1/27. That's very, very, very close to the x-axis. When x is -1, the y value is -1/9. Still very, very close to the x-axis. When x is 0, y is -1/3. When x is 1, y is -1. And when x is 2, y is -3. So you can see this is actually a reflection on the x-axis as well as a vertical compression. Okay, so let's talk about some vertical and horizontal shifts as well as compression and stretching. So keep in mind, and we do have these functions right here, the h factor is going to be your horizontal shift. And remember, if it's -h, it's going to be to the right, and if it's +h, it's to the left, same as before. The k value is your vertical shift factor, so +k is up, -k is down. One of the things that's going to happen when you have a vertical shift, and that is your k factor, is that your asymptote, your horizontal asymptote, is going to change. And so let's take a look right here. It shifts the horizontal asymptote, and no longer is it the x-axis, which is the line y equals 0, but it changes that asymptote to the line y equals k. Okay, if you take a look at this function that we're going to graph, all we have here is a horizontal shift. We have a -4, and remember, minus means to the right. So this is going to have a shift to the right by 4 units. Now, here's what this means for us doing our table of values. It means that instead of using 0 as our middle number as we went -2, -1, 0, 1, and 2, we want to use that 4 as our middle number. So we're going to go 2 below it, which is 3 and 2 above it, which is 5 and 6. And now I'm going to have that table of values. So when x is 2, my y value is going to be 1/4. So it's pretty close. Let's get it down there. Get it down there close to that x-axis. When x is 3, y is going to be 1/2. So let's get that drawn in. When x is 4, y is going to be 1. When x is 5, y is going to be 2. And when x is 6, y is going to be 4. So you can see that what's happened here is that the whole graph has shifted to the right. And you can see, since we didn't have a vertical shift, your asymptote is still the line y equals 0, which is the x-axis. I'm hoping that you're noticing that on the bottom of every slide you'll see a page number and problem numbers, as you can see right down here. That tells you what page number and problem numbers are like the problem that we're doing, so it can help you know what are you supposed to do on what problems on the homework. Okay, so let's take a look at this graph that we're graphing, and you can see this time we are not going to have a horizontal shift, but we are going to have a vertical stretch, and that is because of the 3 here, and we are going to have a vertical shift down 4 units. So this is going to change our asymptote, and I always find the best way to do this is to take a look at your graph first before you guess. However, we know this. Because our asymptote, because our vertical shift has shifted our graph down 4 units, our asymptote is the equation y equals k. So it's going to be y equals -4. But let's go ahead and graph this so we can make sure that that's the case. Because we have no horizontal shifts, we can go back to using -2, -1, 0, 1, and 2. And let's go ahead and graph this. So when x is -2, we have y equals 8. Y. This seems to be off the graph a little bit. Let's see if I can get a point to appear here. There we go. Okay, when x is -1, y is 2. Here we go. Let's see, when x is 0, y is -1. When x is 1, y is -2.5. And when x is 2, y is -3.25. And where that is heading is down to that line that y equals -4. So let's see if I can draw this graph in here. See, I have the same difficulties you guys have when you're trying to graph and explain everything. So there we go, down to the line y equals -4, which is the horizontal line at -4. Okay, I've got to introduce you to a new number. A new number, that number is e. E is a lot like pi. It is a symbol, and it means an actual number, and that actual number is a horrific decimal. And in fact, here is what E equals. E equals 2.7182818828, and it keeps on going, and it never ends and never repeats, so it is irrational. The interesting thing is we can have exponential functions with the base e, and the ones we've been doing had bases like 2 and 3 and 1/2, but we want to get used to the base of e because we're going to need that later in chapter 7. So what I want to show you in this particular slide is how to do calculations with E on your calculator. So you see a lovely little picture of your calculator here. There's a couple keys you're going to need. The second key right here. If you look at the division symbol key, right up above it in blue using the second key is the letter E. And if you go over to this key that says ln on it, and you go above here, it says e to the x, and that allows you to put in e raised to a power. So here's what we're going to do. We're going to use these keys to figure out e to the third. And so there's a couple ways you can do it. You can put in the e by using second and then going over here to this key, then using the caret key and raising it to the third power, in which case here's what you'll get, 20 point blah 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 blah. Or we can do e to the eighth like this. What we're going to do is just go second down to e to the x, and then it's actually going to put the little exponent in, and you're just going to put an 8 there and click enter. And when you do that, you're going to get 2,980 and yada yada yada. Here we're going to use E actually to compute continuously compounded interest. And we've got a formula for that, and you'll see that formula right here. A of t equals P times E to the RT. P is the principal, that's how much you're saving. R is the interest rate, and you're going to need that actually in a decimal. And T is the time in years. Let's go ahead and do an example. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? So here's what we've got. Whoops, need to turn the pencil on. Got the pointer on. So A of 4 equals 3,000 times e to the 0.05 times 4 power. And we can put this right in our calculator. And we get about $3,664. So how much will be in the account after 4 years of high school? So that's in essence 8 years after it was put into the account. So here's what we're going to do. A of 8 years equals 3,000 times e to the 0.05 times 8. And let's put this in our calculator. And we have about $4,475.